Welcome to our deep dive today. We've got a really cool topic you all sent in, a whole bunch of research on pyrolysis,
Oh, yeah.
and specifically how it can be used to break down everyday waste.
Right.
You know, like that furniture wood,
Hmm.
plastics,
Yeah.
even tires,
Yep.
into usable fuel.
That's right.
So it's pretty amazing stuff.
It really is. It's almost like alchemy, but,
Yeah.
a much more practical outcome.
Yeah, exactly. The potential is just so captivating, right? Like, imagine if we could actually, like, shrink those mountains of waste we produce,
No lie.
and then at the same time, create this renewable energy source.
Yeah.
That's really what pyrolysis is all about.
It's certainly a compelling idea.
Yeah, absolutely. So the core of our deep dive today is this research paper
Okay.
titled Co-pyrolysis of Furniture Wood with Mixed Plastics and Waste Tires. Assessment of synergistic effect on biofuel yield and product characterization under different blend ratio.
Wow, that's a mouthful.
It is, but it's really fascinating because it gets into like all the nitty-gritty of what happens when you start mixing and matching
Yeah.
these different waste materials in this pyrolysis process.
It is a fascinating area of research,
Yeah.
particularly the concept of synergy in co-pyrolysis.
Okay, I'm all ears. Tell me more. But before we get too far, I think it would be helpful for anyone who might not be as familiar
Sure.
to break down what pyrolysis actually is.
Okay, so at its core, pyrolysis is a process where you heat materials to very high temperatures.
Okay.
But, and this is really key, in the absence of oxygen.
Oh,
So it's not like burning things
Right.
we usually think of.
gotcha.
It's more that the intense heat causes the materials to break down
Yeah.
at a molecular level.
Okay, so no open flames or billowing smoke.
Not in this process, no.
Okay, I got it. But why is this so interesting? Like, why are we even talking about this for
Yeah.
waste management? You know, we're talking about things we usually just try to, like, get rid of.
Right. Well, it's about taking a problem
Yeah.
and turning it into a potential solution.
Okay.
So just think about all the plastic and tire waste that we generate.
Oh, globally, it's massive.
Globally, millions upon millions of tires end up in landfills
Every year.
every year, taking up space,
Yeah.
leaching harmful chemicals.
Into the environment. Yeah.
Exactly. And so pyrolysis offers a way to convert this waste
Yeah.
into something valuable.
Okay. Yeah.
And that's where that idea of turning trash into treasure really comes in.
Totally. Yeah, that's a powerful shift in perspective for sure.
Right.
Now, this research paper we're looking at today, it dives into the specifics of using a fixed bed reactor
Okay.
to actually pyrolyze these materials, like
Mhm.
furniture wood, plastics, tires,
Okay.
both individually, but then also in all these different combinations.
Right.
So what were they trying to figure out by doing that?
Well, they were very methodical in their approach. They very carefully measured
Okay.
the yields of different products that came out of the pyrolysis process.
Okay, so like what? Like liquid fuel?
Yeah, liquid fuel,
Yeah.
char,
Yeah.
gas.
Okay.
Their goal was to really see how mixing these different waste materials affected
Yeah.
what they got at the end.
So they're playing around with all these different like waste recipes to see what gives the best result.
Exactly. They were particularly interested in something called synergy
Okay.
in co-pyrolysis,
Mm-hmm.
which is this idea that sometimes combining these materials
Right.
can produce an even better outcome
Yeah.
than just the sum of its parts.
Okay, interesting. So like the whole is greater than the sum of its parts kind of thing.
That's a great way to put it.
I'm already curious, was this synergy something that we're expecting to see, or was this like a surprising discovery for them?
Well, in this case, they actually did find a significant positive synergistic effect
Okay.
when they co-pyrolyzed mixed plastics and waste tires.
Interesting.
So this dynamic duo actually yielded more liquid fuel
Oh.
than you would predicted
Mhm.
based on just how they perform individually.
Okay, so it's not just like throwing anything and everything into this pyrolysis reactor.
Right.
It's about finding the right mix.
There's a real science to it.
Yeah, totally. But this liquid fuel we keep talking about,
Yeah.
what exactly is it made of?
Well-
I know they use some pretty high-tech methods to analyze it, like FTIR
Right.
and something called GCMS.
Yeah, so they used some very sophisticated analytical techniques.
Correct.
So the FTIR, that stands for Fourier Transform Infrared Spectroscopy,
Right.
that helps identify the types of chemical bonds that are present in a sample.
Okay.
And then that gas chromatography mass spectrometry, the GCMS,
Yeah.
that separates and identifies the individual components
Right.
of a mixture.
So it's like a molecular fingerprint scanner.
That's a great way to put it, yeah.
Cool. So we're not talking about just like some mysterious goo.
Right.
Here, we're talking about identifiable compounds.
Yeah, absolutely.
So what kind of things did they find in this fuel?
So they found a complex mix of hydrocarbons, some of which are quite valuable.
Interesting.
For instance, they found azulene,
Vaseline.
which is a dark blue aromatic compound.
Oh, azulene. That rings a bell.
Yeah, you might recognize it from the world of cosmetics,
Oh, yeah.
often used as a coloring agent.
Okay.
It also has some interesting anti-inflammatory properties.
Oh, wow.
They also found tetraidocane,
Okay.
which is another valuable compound used in perfumes and as a solvent.
That's fascinating. So we're not just talking about basic fuel here.
No.
There's all these potentially valuable byproducts in the mix as well.
That's right.
So it's almost like a molecular recycling system where every part of the waste gets utilized.
Yeah, it's a great way to think about it.
Wow, this is getting more and more interesting by the minute. But tell me, how does the quality of this fuel stack up against something like traditional diesel?
That's where we look at something called heating value,
Okay.
which essentially tells us how much energy a fuel releases when it's burned.
Okay, so like a higher heating value means a more potent fuel.
Exactly.
Gotcha.
So the liquid fuel derived from the mixed plastics alone
Okay.
actually boasted the highest heating value,
Wow.
clocking in at an impressive 44.08 megajoules per kilogram.
Okay. I'm assuming that's good. How does that compare to just like conventional diesel?
Well, for comparison, traditional diesel fuel comes in at 42.8 megajoules per kilogram.
So the fuel for mixed plastics actually has like a bigger energy punch
It does.
than regular diesel.
That's right.
Wow, that's a significant find. I mean, how might that impact, like how feasible pyrolysis is?
It certainly adds to its appeal.
Yeah.
The blend of mixed plastics and waste tires also performed well.
Okay.
It had a heating value of 41.71 megajoules per kilogram.
Oh, wow. Still higher than diesel. What about the fuel from the wood, plastic, and tire combination?
So that blend had a lower heating value, coming in at 32.54 megajoules per kilogram.
Okay, but it's still usable as a fuel source.
Precisely. Might not be as energy dense as the others.
Yeah.
But definitely not without its value.
It's This is incredibly promising.
Yeah.
It just seems like no matter what you put in this pyrolysis reactor, you get something useful out of it.
It's quite remarkable.
It is, but before we get too carried away, I'm sure there's got to be challenges.
Oh, there always are.
Right.
Of course.
With scaling this up from the lab.
Absolutely. To the real world.
As with any new technology,
Right.
there are hurdles to overcome.
Yeah. Okay, well, let's delve into those in part 2 of our deep dive.
So scaling up any technology always comes with, its own unique set of challenges.
Right.
And in the case of pyrolysis, one of the key things you have to consider
Yeah.
is controlling the composition
Okay.
of that waste stream
Right.
that's being fed into the reactor.
Gotcha.
Because different materials break down in different ways.
Right.
And that can really affect the overall yield
Yeah.
and quality of that fuel that's produced.
So it's not as simple as just like rounding up all of our trash.
And just like chucking it into some giant pyrolysis oven.
No, it's definitely
There's an art to it.
more nuanced than that.
Okay.
Yeah, you have to be much more thoughtful
Right.
about the types
Yeah.
and the proportions
Yeah.
of those materials
Okay.
that are being processed.
Gotcha.
That means developing efficient sorting and pre-treatment processes
Right.
to ensure a consistent and optimized feedstock.
Okay.
And then there's also the engineering side of things, right?
Right.
Designing reactors that can handle
Right.
these large volumes of waste
Yeah.
efficiently and safely.
Yeah, I bet safety is a huge factor here too, right?
Absolutely.
Especially when we're dealing with those high temperatures
Right.
and all these potentially like flammable materials.
Huge, yeah.
Yeah.
Safety protocols and risk assessments, those are paramount in any
Yeah.
industrial process, right?
Yeah.
But even more so when we're talking about,
Yeah.
waste-derived fuels. So it's a very complex interplay of chemistry, engineering, and then those safety considerations.
It sounds like taking pyrolysis from the lab to an industrial scale is like a very multifaceted challenge.
It is.
So what about like the economic side of things? Can this even compete with
Right.
our existing waste management and energy production methods?
That's a very important question.
Yeah.
Because we can't just focus on those environmental benefits, right?
Right.
It has to make financial sense as well.
Yeah, of course.
So the economic viability of pyrolysis really hinges on a lot of factors,
Okay.
including the cost of, collecting and sorting the waste, the energy requirements of the process itself, and then, of course, the market value of the fuels of those byproducts that are produced.
It's a very complex equation.
It is.
But I want to go back to the research for a second.
Sure.
You mentioned earlier, they analyzed the chemical composition of the liquid fuel using that technique called GCMS. Was there anything that really stood out to you from those findings?
Well, you remember we talked about identifying those individual compounds that were present?
Right.
In the fuel?
Yep.
They found that mix of hydrocarbons, including that azolene for the cosmetics, that tetraidocane for perfumes and solvents.
Yep.
But one particularly intriguing thing that they found, when they analyzed the fuel from that blend of wood, plastics, and tires, they found a compound called ethisterone.
Ethisterone? I don't think I'm familiar with that one.
You may not be. It's actually a progestin. Which is a type of hormone that was once used in medicine.
Oh, wow.
Particularly for treating certain gynecological conditions.
Wow. So from tire scraps to hormone therapy, that's a recycling story I did not expect.
It is fascinating.
It really highlights all the unexpected potential that we can unlock through pyrolysis. We're not just creating fuel.
Right.
We're uncovering all these hidden values in materials that we just typically discard.
It really speaks to the power of chemistry and how all these different fields are interconnected.
Absolutely. But let's talk about the fuel itself.
Okay.
We know that mixed plastics blend had the highest heating value, right?
Right.
Even surpassing diesel. What about the other combinations? How do they compare?
So that blend of mixed plastics and waste tires also performed very well. It had a heating value of 41.71 megajoules per kilogram.
So another win.
It is.
For that combination of materials.
Yeah.
What about the fuel from that wood, plastic, and tire blend?
That one had a lower heating value at 32.54 megajoules per kilogram.
Okay, so not as energy dense.
Right.
But still, respectable.
Absolutely.
It seems like I'm noticing a theme here, regardless of the specific combination.
Pyrolysis can get us valuable fuel from these waste materials.
It's very promising.
Yeah, it is. But, back to those challenges of scaling this up.
Right.
Where do we go from here?
Right.
What are some of the key areas where we need more research?
Well, one area that definitely needs more attention is how do we optimize the pyrolysis process itself?
Okay.
How can we fine-tune those operating parameters?
Yeah.
Like the temperature, the pressure,
right.
the residence time to really get the most out of those different waste materials.
Yeah.
We need to really develop a much deeper understanding of those chemical reactions that are happening during pyrolysis and how all those variables influence that final product.
So it's about finding the sweet spot for each type of waste.
It is to maximize the fuel yield and the quality.
What about those valuable byproducts we've been talking about?
Could those be extracted and utilized even more effectively?
That's another exciting avenue for research, for sure.
Yeah.
Imagine if we could not only create fuel, but also harvest valuable chemicals and materials from the pyrolysis process.
It'd be like a double win for their sustainability, resource management.
Absolutely. It'd be like turning our waste stream into a treasure trove of resources.
It's such a compelling vision.
It is.
But I am also wondering about the environmental impact of the process itself.
Right.
Because we're trying to create this more sustainable system.
Right.
We don't want to create new problems in the process.
Of course, of course.
What about the emissions from pyrolysis?
Well, that's a crucial consideration.
Yeah.
And I think it's important to emphasize that pyrolysis, when done correctly, can be a very clean process. Because remember, we're heating those materials in the absence of oxygen.
Right.
So we're not dealing with the same kind of combustion and harmful emissions you get from burning trash.
So no giant plumes of smoke?
No.
Billowing from pyrolysis plants?
Not at all.
That's reassuring.
It is a very different process.
Okay, but there's got to be some emissions, right?
Well, of course.
What are we talking about here?
You're always going to have some emissions.
Right.
But they're primarily gases like methane, carbon monoxide, and hydrogen.
Okay.
And this is where it gets really interesting.
Okay.
Because these gases can actually be captured and utilized as fuel themselves.
Wait, so we're talking about a system where even the emissions become a resource.
Exactly. It's that ultimate waste-to-energy efficiency.
What about that solid byproduct, the char?
Right.
What happens to that?
So the char can also be used in lots of different applications.
Oh, okay.
It can be used as a soil amendment.
Okay.
Improving soil fertility.
Yeah.
Water retention.
Okay.
It can also be used as an activated carbon.
Right.
For filtering pollutants from water or air.
Oh, cool.
And some researchers are even exploring its potential in building materials.
Wow, the possibilities seem endless. We're not just creating fuel here, generating all these like valuable resources from what was previously considered waste. It's like a paradigm shift.
It is.
In how we think about garbage. But before we wrap up, I want to go back to that economic viability of pyrolysis that we were talking about earlier.
Right.
You mentioned that like it needs to compete with existing methods.
It does.
What are some of those economic hurdles that we need to think about?
So one key factor is the cost of the technology itself.
Right.
Building and operating these pyrolysis plants requires a very significant upfront investment.
Of course.
And then there are the ongoing costs
of
collecting, sorting, and pre-treating the waste.
Yeah.
So we need to develop more efficient and cost-effective methods.
Right. So streamlining the logistics, bringing down the cost.
Absolutely. For those stages of the process.
What about the market for the fuel and the byproducts? Like, is there enough demand to even justify the investment?
That's another critical piece of the puzzle, right? We need to make sure that there's a stable and growing market for that fuel and all those products that come out of pyrolysis.
Right.
This might involve, government incentives to encourage people to adopt these alternative fuels and materials. It might involve partnering with industries that can utilize those byproducts in their manufacturing processes.
It sounds like there's a lot of work to be done.
There is.
But the potential rewards are like enormous.
Oh, they are.
Like we could like revolutionize how we manage waste.
Absolutely.
Reduce our reliance on fossil fuels.
Right.
And create a more circular economy.
It's a vision worth striving for.
It is.
And the research that we've been talking about today really highlights how remarkable pyrolysis can be.
It really does.
In helping us achieve that vision.
It really feels like we're on the cusp of this like waste management revolution.
It does.
We've talked about, the potential of pyrolysis to create fuel and those valuable byproducts and even utilize its own emissions.
Right.
But what does this mean for like the average person? Like how could this actually impact our everyday lives?
Well, that's the exciting part, right?
Yeah.
Envisioning how this could reshape our world.
Yeah.
Imagine a future where instead of those overflowing landfills, we have pyrolysis plants integrated right into our communities. Transforming, what was once considered waste into all these valuable resources.
So like our trash cans become these mini gold mines.
In a sense, yeah.
Yeah.
We could see this really big shift from that linear take, make, dispose model to something way more circular.
Yeah.
Where those materials are constantly being reused and repurposed.
I can already picture it like those futuristic cities where everything is like interconnected and sustainable.
Exactly.
But okay, let's come back down to earth for a minute.
Sure.
What would it actually take to bring pyrolysis from like these research papers to something that's like part of our daily reality?
Well, it's a multifaceted challenge.
Okay.
First and foremost.
Yeah.
We need that continued investment in research and development.
Okay.
There's still so much we're learning.
Right.
About optimizing that pyrolysis process.
Yeah.
Tailoring it to those different waste streams. And really maximizing the value of those products that it generates.
So more science, more tinkering in the lab, Yeah,
exactly.
Figuring out how to make this work even better.
We're not quite there yet.
Okay.
And along with that scientific progress, we need to really foster that collaboration.
Okay.
Between the researchers, the policymakers, and those industry leaders.
Yeah. It takes a village, right?
It really does, because it's going to take this, big concerted effort to create that infrastructure, the regulations, and those market incentives to support it.
So it sounds like we're talking about a system-wide change, not just a technological innovation.
It's way bigger than that.
Wow, this has been an incredible deep dive
It has.
into the world of pyrolysis. We've gone from like the molecular level to like the global scale,
Big topic.
exploring all this potential, of how this could reshape how we manage waste, how we generate energy.
Right.
I gotta admit, I'm feeling pretty optimistic about the future.
It's an exciting time to be following this.
It really is.
And the more we learn, the more we realize how much potential there really is.
So for everyone listening out there, if you're as intrigued by all of this as we are, keep exploring.
Absolutely.
Dive deeper into this world of pyrolysis.
Yeah.
Follow the research, and who knows, maybe you'll be the one to unlock its full potential.
That's right. That journey of discovery continues.
That's right. It definitely does.
We're just getting started.
That's a wrap on today's deep dive.
Awesome.
We covered a lot of ground today.
Yeah, we did.
But hopefully you've all come away with a sense of just how powerful pyrolysis can be.
It is.
And all that potential it holds for this more sustainable future.
Very exciting.
So keep those questions coming, keep learning, keep an eye on the horizon for all those exciting innovations that are coming our way.
Absolutely. Thanks for listening, everyone.
Thanks for joining us.